The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
We want to be that value-added partner, and we're kind of unique in that we're not just trying to get every project under the sun. Our strength is that we have 100% focus on the solar industry, and so we want to stay on top of those trends. And like I said, we're focused on the C&I market and the small-scale utility market. So those trends are really important to us. And, I'd like to come out with these earth-shattering, great technology ideas, but rather it's just kind of being in touch with the pros and cons of what's happening.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, C&I Solar and Storage Engineering. My guest today is Steve Schwerd. He is the principal and owner of Schwerd Consulting. Welcome to the show, Steve.
Thank you, Tim. Good to see you again. I'm a regular listener. I appreciate what you do for the industry.
That is so nice of you. And I think that's one of the things that made you and I click right off the bat when we met in Dallas at the Chint Power Systems Innovation Day. If you don't know about the CPS event, it's an annual innovation gathering of EPCs, engineers, consultants, and solar professionals, and it's a lovely event. It's a great way to meet other solar professionals. Reach out to your Chint representative and ask questions about that event. You want to get invited to that. That's how you and I know each other. I have to say, I've just gone to that event 2 years in a row now, and it was a quantum leap, though, for me, just the value that I got out of it. I knew how to work the room a little better this time. But Steve, tell our listeners a little bit about yourself. How did you get into the solar industry? What's your background, and what do you do at Schwerd Consulting?
I'm an electrical engineer by background, right here in good old New Jersey, where we're located, from Rutgers University. And then my career was spent in let's call it the building industry, the architectural industry, starting as doing electrical designs for commercial, industrial, institutional buildings for MEP engineering firms, mechanical, electrical, plumbing. And through the course of my career, I grew from designing and lead engineering to project management, and then getting involved in team management and firm management, both for small engineering firms, understanding that dynamic, growing teams from initial startup to running engineering nationally for a large architectural and engineering firm, where I had multiple disciplines: the mechanical, electrical, plumbing, fire protection, structural, civil, and environmental under my wing. And then I was really involved in my career in some energy intensive markets where it was critical to design and engineer systems that reduced energy consumption. And out from there, sustainable design and lead projects. Got involved in that very early in the lead adoption, and I really had a passion for sustainable design. And that's what opened up the introduction to the solar industry. For early in the sustainable design practice, we would look at adding solar and solar photovoltaics to projects, but I wasn't impressed with them, and they often didn't pencil out. We're talking the late 90s, early 2000s. And in doing sustainable design, just like in solar, one of the things we always talk about was like the triple bottom line, and it has to work for everything. So it has to be, you could almost call it the three Ps, right? People, planet, profits. So it's got to be good for societal benefits. It has to be good for the environment, good for the planet, but it also, to make it work, it has to be profitable. It has to have a bottom line positive economic impact. And so the solar, in most cases, was not doing that. So either it didn't get brought into our lead projects, or it became, we're gonna pay for it. We're gonna accept really low returns, but we want a lot of energy reduction, a lot of points to get a high rating of our lead projects. But as time went on and we got into the later 2008, 2009, those same conversations where I had not a great feeling about solar, I started to get involved with people in the industry that were wiser, more technical savvy. Things started making sense. And depending on the area you were at, all of a sudden, it was starting to become a viable economic alternative. And from that exposure to some good solar industry people and companies, it took me out of just adding solar into designing building projects, but into actually starting to work for solar companies to design and engineer their solar plants. And
let me interrupt you there. I think we want to shine a light on, if you would, Steve, what is the state of the C&I solar industry as you see it? You're working in, I think, 14 states.
and more now.
Okay. And it is such an interesting niche because it is a tough nut to crack. A lot of real estate is third-party owned, meaning it's not owner-occupied. Upwards of 90% of commercial real estate is third-party owned real estate. Now, there are innovative platforms coming to market to unlock that, but traditionally, C&I solar installers and developers are looking for owner-occupied facilities to solarize, or now in the 2020s, solar and storagize. But from your perspective, you've seen the industry mature tremendously. The modern solar industry in the U.S. started in 2010, even though you will run into professionals like yourself who were working with PV as early as 2000 or the early 2000s or the late 90s. Check out my interview with Ryan Mayfield and Mike Hall, for example, of ANZA. Right. But for some of those very early adopters, how would you capture the state of the C&I solar and storage industry in the U.S. today?
I would say it's certainly come a long way in many perspectives, including the quality of the installation, the quality of all industry partners in it, from the owners of the solar to the engineers to the installers, the contractors. But it definitely is a robust market. Still, there's typical with solar, it can be very state dependent, right, on their policies and on the utilities. But as you talk about the ownership of these buildings, and so there might be third-party ownership where the tenants aren't controlling it, unless you have to understand there are types of facilities where the tenants have roof rights, right? Because they do a lot. For instance, a supermarket would typically always have roof rights. But I think the community solar, as community solar grows, that has been a big avenue in maybe dealing with additional challenges too, because that opens up the buildings, right, to the third party owners. It also can deal with many states that have net metering limitations where you cannot produce more energy from solar than you use annually. Warehouses across the country,
Yep.
their energy consumption may be fairly low. So you can have a very large rooftop and only take up a small portion of it that is allowed for net metering, the max you can put there. But now with community solar, you can now maximize that rooftop and supply it because it's not part of a net metering installation.
Yeah.
So we've seen a lot of growth in many different markets as a result of that. But we've also seen, as you and everyone has, is I think there's policies that change it, that play into it. Great market, great SREC market, what have you, and that grows it. But there's also just a greater confidence in the solar photovoltaic market, whether it's from an end user wanting to purchase it, to PPAs, what have you. There's just a lot more confidence in the industry as it grows and as it matures to enter into it that I think plays a real factor beyond just the numbers.
Yeah, I'd like to geek out a little bit on some of the trends that we see in the C&I solar and storage market. As you mentioned, the technology, the quality of projects is improving, consumer confidence is improving. We're still down here on the S-curve. We're starting to see some significant growth. We're going to 10x the solar industry in the U.S. in the next 20 years. And so it's a great 20 to 30-year opportunity for young professionals. And even mid-career or late career professionals have plenty of runway in the solar industry. And a lot of people are coming from other industries now. Solar is growing way faster than the fossil fuel industry, luckily. And that is how we gauge the energy transition. But
just
yeah, go ahead.
To stop you there, but yeah, following up on that thought, and I did listen to your recent podcast with the team specifically dealing with the hiring and staffing for the solar industry. And it's really spot on. It's a challenge to, let's say, where we stand from, to find experienced senior engineers. So it's a great market. And I've been encouraging young engineers and young people of all walks of life. This is a market that you can enter and grow rapidly in because of the needs of companies. And it doesn't matter if it's a developer, a PC, a vendor, an engineering firm. There's so many opportunities and you could learn at an accelerated pace. And in 5 years, you are going to be so desired because as opposed to other industries, you're dealing with veterans throughout and the competition is much greater. So it's a great market for young people, even coming straight out of college, to get into.
Absolutely. And we now see a cadre of professionals who have done nothing but solar in their career. And that's really cool. But Steve, let's talk about some of the nuances in C&I solar that are on the minds of our EPC and developer customers and listeners. You and I mentioned UL 3741, which is related to rapid shutdown. And this is about power electronics and safety. And then technology trends like large format solar modules. So paint a picture, if you would. As an engineer, you're getting leaned on pretty heavily by your customers. These are solar developers and solar installers to really be an expert on the NEC, right? The National Electric Code. What are some of the important things that installers are wrestling with and needing to understand around the NEC?
Yeah, and it's the NEC and even beyond, just changes to equipment and inverters and what have you. But you're right, and that's what our goal is. We want to be that value-added partner, and we're unique in that we're not just trying to get every project under the sun. Our strength is that we have 100% focus on the solar industry. And so we want to stay on top of those trends. And like I said, we're focused on the C&I market and the small scale utility market. So those trends are really important to us. And I'd like to come out with these earth-shattering, great technology ideas, but rather it's just being in touch with the pros and cons of what's happening. And I think it's important too, for the line of work we're in, is not to say you have to do it this way, you have to do it that way. There's pros and cons, and we have clients for different reasons, or even contractors, subcontractors, electricians, we know that have different preferences based on their capabilities, based on their buying power, et cetera. But we'll start with the rapid shutdown issue, because it's definitely a challenge. Rapid shutdown, module level rapid shutdown was enacted in the code, evolving to where it became module level with the intent to create the greatest amount of safety for particularly firefighters on the roof. But what has happened in this endeavor to achieve it, there's been a lot of failure of particular rapid shutdown devices. And we can go on. That could be a whole different podcast of issues. Now, there are learning curves. It's gotten a lot better with the understanding of the best design, engineering practices, installation practices, and then even what the vendors need to do to safeguard against it. But what UL 3740 has done is it's now given you a choice to eliminate the module level rapid shutdown by having racking certified in combination with the inverters. And that is a great way to reduce risk. And when I talk about risk, I'm talking about thermal events that could come from rapid shutdown devices, which has unfortunately become a little bit of a bane of existence of those in rooftop solar right now for C&I, and we're encouraging all our clients to really go and check on existing operating installations, in addition to the greater knowledge of moving forward in installations. So that risk reduction, it is huge, but it's not as easy as it sounds. And that's why in solar, it's often not a one approach fits all. If you have a very large rooftop, and now you're going from typically the approach, let's say we recently did a 5 megawatt rooftop in New York State, and it was desired to go with the UL 3741 certification, UL certification. But what that meant is no longer do we have centralized string inverters, but now it is back to distributed and with the inverters by the racking. And so what that does now is that means you're running a lot more AC conductors versus DC conductors. And DC at 1,000 volts versus AC at 480 volts. So you have a lot more voltage drop. And on the AC side, you really want to keep your AC voltage drop down, because AC is a direct loss to your production and essentially your revenue. Whereas DC had a lot more flexibility in its voltage drop losses. So not only was there less voltage drop at a higher voltage, but you could actually have let's say, and I won't go into all the details here, but let's say you had a 2.5% voltage drop, right? Comparatively, if you have a 2.5% AC voltage drop, that's a lot for a PV system, because that's a direct loss. But if your DC voltage drop is 2.5%, you might actually realize only 0.5%, 0.7% loss, because of the fact that at your peak performances, your DC is clipping. So anyway, that's my long.
So let's step back for a sec. I love this. I love this level of detail. Rapid shutdown is a double edge. For one thing, as you referenced, there's multiple ways to solve the problem per se, right? And we've had the introduction of a whole variety of power electronics. These are module level, or oftentimes now a couple of modules per device, module level power electronics, MLPEs. And those are great because they're right there on the solar panel, embedded in the solar field. But that also means many more connectors, many more electronics, many more points of failure. So that's one approach. Does it work? Yeah, it works. Is there a trade-off? Absolutely. And then you have just the use of string inverters, and then the combination of string inverters and racking, and putting the string inverters in very close proximity to the array, and you can solve rapid shutdown that way. That's something.
You do have two other options.
Okay, so yeah, just paint a picture for us. What are the main ways of solving rapid shutdown?
So again, the two you mentioned are correct. The racking, the ML rapid shutdown devices from a couple of vendors, but then there's also the right, that work differently than just the rapid shutdown devices. So I put them in a different category. And then there is another one on the market that does not use power line communication. And that runs 24 volt DC wiring with just a signal to turn on and off, tied into the inverters through a power source. A lot less applied that one is, and that one's had issues as well. But I just wanted to point it out that there are multiple ways to attack it.
Yep. But do you see a pattern or a trend that more asset owners are preferring over one? What is the preferred trend?
Much to my initial, I would say there's a couple approaches, but I think the UL 3741 is being much more intensely looked at and applied, again, even at greater costs, and sometimes significantly greater costs if you have a very large system, large rooftop system, or a disjointed system that's not even and allows you to just perfectly size your array blocks to your inverter blocks. But because of the risk reduction, and I often say people live out of their negative experiences. Anybody who's been involved in a fire on a rooftop, they're going to tend to move to the ultimate safer or even perceived safer intent. But then there's also, we're seeing a much greater move to the vendor with the Optima, and that people can have complained about certain failures, but they fail by device failure, causing a couple modules to not produce versus having thermal events.
Yeah. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. So, what other trends would our installer and developer listeners be dealing with? We talked about solar modules getting bigger, greater energy density. Some of these solar modules are approaching the size of a sheet of plywood for the C&I market, C&I and utility. Truly, they're literally approaching 4 feet by 8 feet in physical dimension. They're still a little smaller than that. And there's all kinds of concerns with that. There's the increase in hail events across the U.S. There is a trend. And when you make these modules bigger, they're heavier, they're harder to handle. So there's the concerns for worker safety. But what do you see in other technologies that is noteworthy?
I'll stick with that topic if we can, right? Those larger modules, right, which are approaching 600 watts and in some cases 625 watts. We're seeing the widespread acceptance of that on the use of carports, canopy structures. Typically, most all the ones we're doing are using those larger modules. And ground mounts, even in the CNI and small utility scale, we're seeing the movement to those larger modules, right? Easier to work with at grade and everything that goes with it. On rooftops, we're definitely seeing a split approach. A number of contractors, installers, they prefer not to work with them because, like you said, bringing them up to the roof, working with them on the roof, it presents a greater challenge, and even in cases more man hours, adding cost to it. But the one thing I try to do is, but others love it, right? They love the power density that comes with it. Sometimes the pricing, the total cost per watt has been an improvement, but I try to point out things too, as long as you're considering other factors as well. As they keep getting larger, right, that density and that extension, when you're in a snow region, now you have to start thinking more about the point loading, right? Because if your rack now that you're using still has just the legs at the end of the module, now you're loading much heavier in taking into account the snow mass and the snow code load allowance at greater intervals. And so often, even now when they've been at the smaller range and 6 feet wide, a lot of times you may see the steel joists at 6 foot centers. So you really don't have an issue. But now you go to 8 feet, you really have to be concerned about how it lays out and overlapping. That it's another factor to consider in your evaluation of the roof framing, and even some of the vendors ballasting, right? In those larger modules, there may be an additional tray or more ballasting into it. And again, just increasing potential for point loading, depending on how that particular rack system holds the blocks. So that's why we try to just point out the factors, pros and cons, and let people make an informed decision.
Yeah, there's no easy answer. There's market pressure to increase the size of the panels, right? That energy density is a good thing in some scenarios, but there are clearly trade-offs. And in general, there's a signal emerging about microcracking in solar modules, and so as the footprint of the module gets bigger, the risk of microcracking does go up. And I want the manufacturers to work closely with one another and make sure that the racking that's available and cost effective is going to work well with those modules. Sometimes the module makers get ahead of themselves, and they just need to remember that it has to work together as a system.
And with all aspects in an emerging technology, a growing industry, so that has vendors working in that their product that might be great, no matter what it is, it has to be compatible with other items in the market, just like we've seen with my issue with the whole rapid shutdown advancement in the code, while trying to do a good thing, was ahead of the technology of the market. And so there was very little choices of what to do. And that rapid deployment of something, maybe before it was ready, turns out to be a negative. And sometimes that's why we see the quality of work today versus when it was the Wild West, like you said, in 2000. And now when we work on modifications, upgrades, additions to existing systems, you see some of that. And then, you see the difference between today's market and that market from years ago when we work on those existing systems. So many vendors, the materials on site are no longer available, right? From the inverter manufacturers that are gone,
Right,
to the racking manufacturers that are gone. And there's a lot that comes into play, making it a real challenge on dealing with it, to the point where there's been times we've had to advise clients that it's probably in your best interest to run some of this until it dies, even at lower efficiency, and then deal with it, or just choose not to modify a system because it's such a high cost that when you wait till your SRECs are done or something like that, and then spend for a full system replacement, it'll be a greater economical model. But
so in our last couple minutes together, Steve, let's talk about solar and storage, or storage alone, right? There are some markets now in the U.S. where there are incentives like New York, like Illinois, frankly, that incentivize storage. California being the top storage market. And then there's markets like Hawaii where storage has been part of the scene for quite long. More on the residential side, they have these very strict non-injection rules, meaning when you install solar, you can't inject solar electrons onto the grid because there's such high penetration, and that causes problems for the grid operator. But what are some of the challenges and opportunities of battery storage in the C&I solar and storage market?
Yeah, it's a great question. And one of the things I used to say, even going back a few years, when people would ask, say, "Oh, have you done a lot of battery energy storage systems?" And I'd say, yeah, we're pretty much like everybody else. We're talking about it all the time, but we're not really doing them. That's changed today. Now, we've just recently completed multiple designs on 5 megawatt, 20 megawatt hour storage systems, and in different states. But like you said, New York's a big market for it. I think one thing that I was surprised it was always, because early on, we'd been dealing primarily with the storage systems coupled with the PV. And that was just my vision of really how it was going to evolve. And now while we certainly are doing that, we're doing a number of standalone direct to the grid battery systems. But as far as challenges go with it, it's really the tying in, understanding utilities, right? Utilities, local fire rules, and what they, may restrictions may have, but also just the material. And that's another thing that's coming a long way. It used to be frustrating for us as engineers needing to design some of these. And it would be, you'd be given a nice, pretty picture of the storage system, but understanding the details that went into it, it would require just one expert involved in it. But now the growth of the industry has really improved the ability to gather the material, design it, engineer it, and work with the parties really on the controller side of it, which is key. I always say, I hate to downgrade what we do, but sometimes the design and engineering of the battery energy storage system is really the easy part compared to making sure that the communication interfaces, the controllers, are properly programmed and operating and are going to work in conjunction with the requirements of the utility and the needs of the finance.
I'm curious, as far as I can tell, there's kind of two approaches. Fully integrated solutions, right, where the storage manufacturer provides a full wrap solution, which includes all of the software, the container, everything. And then there's the integrated approach where you are buying different products and integrating them into a solution, so to speak. Is there a trend there that's noteworthy?
Yeah, we're seeing the move to the fully integrated, whereas early on, you had to integrate the different components. So we're definitely seeing the fully integrated movement, and especially with some of the larger players getting into it and offering that as a solution. And in part doing to that, just greater bankability, right? Greater confidence in the support you'll get.
Of all the storage projects that you see today, what percentage, if you just had to guess roughly, are storage alone versus solar plus storage?
I can only speak for what we're involved in and what we're seeing on our client's side. But I would still say it's a low percentage, perhaps. And this is more than it's been, but maybe 5%.
Yeah. And are there places other than California and New York where this is happening? Storage alone? At the C&I scale. Of course, the utility scale is a different matter. It's utility storage, standalone storage is happening in a much broader playing field. But in the C&I market, it is still today mostly solar plus storage. And that's great, right? Storage adds a whole stack of value to the solar. But for as far as solar storage alone, I know New York has this 5 megawatt market. I assume California has a similar market, but where else are you seeing storage alone? Puerto Rico, maybe?
That's a good question, Tim. Now that I think about it, it's probably limited to New York. We just did a large one, but coupled with the PV in Massachusetts and a few other regions. So I think the number of them we've done are as standalone or just New York.
Yeah.
So I don't know that I can speak confidently enough to all the other markets there.
Yeah.
And even though we're doing solar in so many other states across the country now. I will say, in thinking about it, right, on the C&I side, while I say we're doing battery systems, where we're doing them, we're also doing PV. It's just that they're separate interconnections and often separately tied directly to the utility grid, as opposed to the PV tying in with the facility's electrical service.
Yeah. Cool. Unfortunately, we're out of time, Steve. I want to thank you for coming on the show. Please check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify. Reach out to me on LinkedIn. Check out our YouTube channel. All of our content is on YouTube as well. And with that, I will say, I'm Tim Montague. Let's Grow Solar and Storage. How can our listeners find you, Steve?
I am on LinkedIn, even though I'm not an active social media guy. And email is my first initial last name, SCHWERD @sh.com. Sorry, you got to spell out the whole thing, but feel free to reach out. And Tim, I thank you for having me. Discussions with you are always enjoyable, and keep doing what you do.
All right. Thank you very much, Steve. Let's Grow Solar and Storage. I'm Tim Montague. Take care. Hey, listeners. This is Tim. I want to give a shout out to all of you. I do this for you twice a week. Thank you for being here. Thank you for giving us your time. I really appreciate you and what you're all about. You are part and parcel of the energy transition, whether you're an energy professional today or an aspiring energy professional. So thank you. I want to let you know that the Clean Power Hour has launched a listener survey, and it would mean so much to me if you would go to cleanpowerhour.com, click on the About Us link right there on the main navigation. That takes you to the About page, and you'll see a big graphic, Listener Survey. Just click on that graphic, and it takes just a couple of minutes. If you fill out the survey, I will send you a lovely baseball cap with our logo on it. The other thing I want our listeners to know is that this podcast is made possible by corporate sponsors. We have Chin Power Systems, the leading three-phase string inverter manufacturer in North America. So check out CPS America. But we are very actively looking for additional support to make this show work. And you see here our media kit with all the sponsor benefits and statistics about the show. You know, we're dropping 2 episodes a week. We have now over 320,000 downloads on YouTube, and we're getting about 45,000 downloads per month. So this is a great way to bring your brand to our listeners, and our listeners are decision makers in clean energy. This includes project executives, engineers, finance, project management, and many other professionals who are making decisions about and developing, designing, installing, and making possible clean energy projects. So check out cleanpowerhour.com, both our listener survey on the About Us and our media kit, and become a sponsor today. Thank you so much. Let's grow solar and storage. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.